So thank you. You know, the conversations, the sideboards, they're a big part of why we're all here together. So I'm going to try to get through this and not disrupt them so we can get back to them over lunch. So I'm Wes Fuhrman. I'm the APL lead for the Lunar Surface Innovation Initiative, which includes LSIC, all the things that you're here for, together with Rachel, our director of LSIC, and Brenda Clyde, who's back there. We're like the three-headed monster of the APL LSII activity. So if you need things, don't ever feel bad reaching out to us. We'll also hear in this talk from Josh Cahill, who's our deputy director of the LSIC. I want to take a moment to acknowledge the moment that we're in. You know, this meeting is a fantastic demonstration of how the community's coming together and continuing to build momentum for our return to the moon. And in moments like this, I think it's important to recognize how we got here, and the success that we have is built on the support that we have to get there, right? So that comes from all of you in the audience. We're doing a fantastic job of supporting the LSIC, in part because we are the LSIC. And I especially want to thank Spuds and Nikki and Jim and really all of NASA. It started with them moving this forward. It's fantastic. The topic that Spuds was getting into, way I consider it as the 0-1 infinity principle, right? So for the moon, before Apollo, we were 0, right? And at Apollo, we turned that 0 into a 1. And now we're in the process of achieving an enduring presence. And that enduring presence is how we achieve exploration maturity. And so we're in the process of achieving infinity. It's no small thing, but we're doing that in the process, bringing all of humanity together. And that's something that seems more and more a precarious endeavor as it goes on. It's not just because the goal is so much larger than us, but it requires all of us to look together to the same place. So going to the moon forces us to look at the one place on Earth that anyone can see that's within our capability to reach. So it will take all of us to get there. And my emotional sort of ramblings aside, this is being codified in national policy. And it's no coincidence that that also reflects a lot of what the community priorities are as well. These documents, the Moon to Mars objectives, the OSTP, National Cislunar Science and Technology Strategy document, these things were crafted with extensive community involvement. And so I hope that you see yourselves reflected in these documents. When I look at what we're doing as LSII and with the LSIC community, there's sort of two options. One is that our fingerprints are all over what's happening, or we have a fantastic opportunity to help deliver on the objectives that are being described. So it's actually probably both of these things. And I think it's really a testament to NASA and to the broader community that we're arriving at these objectives together, right? It means that we're building a convergent path towards achieving our goals. And that's how we have this continued momentum to get to the moon. And that's how the United States will lead the return of humans to the moon for long-term exploration and utilization, followed by human missions to Mars and other destinations. So I better get to a little bit to what LSII actually is. So this is out of Space Technology Mission Directorate. Most of you will be familiar with this, but many of you are also newcomers to working with space tech. This is really the engine for developing the technologies that we need for that sustained lunar presence. So formulating and integrating technology across that TRL pipeline, doing so in innovative ways with partnerships that can expedite that technology development, and utilizing the early uncrewed lunar surface flight opportunities to inform some of the key technology developments. We're also going to hear from the CLIPS program tomorrow. That's another fantastic sort of innovative experiment for acquiring lunar surface payloads. So APL's role in LSII also includes operating the Lunar Surface Innovation Consortium. No surprise to those of you who are in the room, but there are other actions and activities that we take on as part of our role as a technical direction agent. So they generally can be combined into these three categories you see here: community liaison, systems integrator, and independent evaluator. And I think that one of the really important things about how we're constructed and how we operate as the three-headed monster and more is that we are tightly coordinated. And as we've heard again and again, that coordination and communication is key towards staying together as we move towards our goals. So I'm just going to go over a little bit of what each one of those buckets entails, and then Rachel will talk a lot more about what's going on within the LSIC. So to give you an idea of what the systems integration task is, this is really key research and development that helps LSII achieve their technical goals. So just some examples here of the sorts of tasks that we take on as part of that systems integration role. We perform illumination analyses of the South Polar region to help optimize landing site selection. What you see on in this figure is that Prime 1 mission that we'd heard about before, which includes the Trident drill and IM-SOLO mass spec. And hopefully we'll hear from the Eclipse provider tomorrow, Intuitive Machines, who's going to fly this to the moon coming pretty soon. I'll let him, won't steal any more of Ben's thunder. We're also working to integrate some of that illumination tool with the microgrid modeling to understand what the impacts are across not just what it is in a single location, but how that would manifest in a power architecture. We do some computational fluid dynamics to help understand low gravity fluid dynamics for ISRU community. And there's additional efforts that we take on coordinated with those principal technologists, systems capability lead technologists. We work as closely as we can with them to meet their needs as well as the needs of the community. So I'll say this probably a dozen times in this talk, but there are open invitations for you to reach out and talk to us, tell us what your needs are so we can help meet them. So in the independent evaluator role, again, it's critical to understand what's actually going on in the community, and we do extensive community engagement and involvement in this process. So this includes things like technical interchange meetings with NASA. We do one-on-one meetings with representatives from industry. We do site visits. We can create NDAs so that you can tell us in as candid terms as possible what's working and what's not working. We also use whatever information that we can to help build the thematic workshops that we take on for the LSIC. We also use that to inform the telecons that we have that informs the broader community. And so staying sort of at that leading edge of whatever's happening, whatever's community priorities they are, we try to meet them and move the needle forward. We also have a deep bench of APL Lunar expertise. There's also an extraordinary amount of expertise just in Maryland, not just at APL, right? We've got an extraordinary set of folks that we can reach out to solve a lot of these problems. So this is the open invitation. What do you need to know next and from whom? We want to help you get there. APL stays integrated closely with Space Tech, but steadfastly independent. That's a big part of APL's charter, is maintaining unquestionable integrity, and I take that very seriously. So I'm not going to tell you everything that you can take away from some of the things that we take on in that independent evaluator role, but here's some that we wanted to share out to this community here. So one thing that I think is reflected in a lot of the talks we've already heard this morning is that our return to the moon tests more than just technologies, right? It stress tests the sustained direction, the funding, the execution across all of these disparate stakeholders. Some technology areas focus on point solutions which have infusion problems. So I love seeing the charts that are coming out of this process that are showing how this all works together and flows towards that. So the more that we can favor mission-oriented development priorities with a tractable path to flight, we can fill out that wireframe in the best way possible. Digital engineering tools are a bit underutilized still, so leveraging industry capabilities can take advantage of extensive private investments. In fact, that theme of translational technologies really abounds. That's one of the things that I think is different from the Apollo era. We have far more technology to bring to bear in our return to the moon, so it's going to look an awful lot different. STMD-led CLIPS missions, so we saw those in Jim's talk too. This is another thing the community really is in favor of, the potential for the coordinated technology development that has built-in mission impact. From the industry side, there's been a call for more rationale behind the specific solicitations. The more that industry can understand the why NASA's trying to achieve something, the more they can innovate and meet it. A long-term commitment is needed to especially for the big translational technology wins. I think we've heard a lot about that through this Moon to Mars architecture, as well as the way that we're collaborating across the whole of government with things like the Draco and TP coordination. One thing that I find continually surprising, and I really have enjoyed about seeing this community grow, is that industry is engaged in participating even in advance of a self-sustaining lunar economy. There's a recognition that this is going to take some time, but we all want to be going there together. So I also want to talk about some of the things that we do as part of the community liaison that aren't just within LSIC. One of these is something that Milena Graziano has been heading up. I'm not sure she's in here. Oh, see an arrow. Where is she? Wave. Oh, they're back there. Great. So this essential compilation of lunar information in preparation of sustained exploration, this is not MUNA 101, but it's Lunar Engineering 101. So this is the key information that we need to bring people in and start them engineering for the lunar surface, using all of the information that we know from having been to the moon and gone to the moon before. So it's cast in terms of the lunar surface environments and characterizing how these impact the technologies you're developing across all of them. Right? So thermal, surface charging, illumination, dust, and regolith, pretty comprehensive across the lunar surface environments. The goal of that is to provide the overview of these environments that need to be considered for proper technology development. What are the characteristics of these environments? What are the challenges that they pose to humans and to hardware? And what are the design considerations that can meet those challenges? So extraordinary amount of work that's gone into this. I really appreciate the team coming together and delivering this. So hopefully we'll be able to debut it soon, probably by the fall meeting, right? Let's see. Yeah. Okay, the other, a little too fast. Another thing that I want to talk about before I hand off to Rachel is the white paper that the community has been developing, as well as the APL team. And that's this paper, white paper. It's the path to an enduring lunar presence. The idea is that by the 2030s, so circa Artemis 8 or so, the lunar infrastructure that could meet NASA's Moon to Mars objectives could support scientific outposts, exploration proving grounds, can also bootstrap commercial activities. So what are the key factors that can enable our nation and the world to move together towards our shared use of the lunar surface? Maybe a little more succinctly, it's trying to answer the question, in satisfying NASA's baseline Moon to Mars objectives, how do we ensure the robust participation from industry that also enables a transition away from NASA as the sole customer? And another point that I think was covered really well, so all of my thunder has been stolen, is that the moon as a proving grounds offers decades of time to develop exploration technologies and perform extraordinary science. It also is a key way that we will demonstrate our commitment and unity of purpose as a nation. And it also is a place where we can test and mature the acquisition strategies that we need to move on to additional exploration objectives. So the way that NASA understands this is that the moon will show us that we're ready to move on to Mars. I think that the corollary for the industry side is that the moon will also show us when we're ready for an expansion of the cislunar ecosystem. So we all know that there are things that we need to learn. If we learn them together, we can enable both NASA's exploration objectives as well as industry and other stakeholders to follow along with what we have developed. So some of the key takeaways from this paper, you can find it in the QR code, and I'll show that again over lunch so you can have that discussion. Achieving that enduring presence on the lunar surface requires consistent intention and funding, maybe patently obvious, but the global lunar community, including a lot of the non-traditional players, are eager to work with NASA to achieve those shared lunar goals. Some of the indicators that NASA can take and others can take to indicate their long-term intentions include interoperability and investing in long-term use technologies such as dust mitigation. Again, this is all stuff that I think rhymes pretty well with what's coming out of the rest of our nation's priority. So enabling access and accommodation, that's what leads to that enduring presence, reusing the infrastructure and developing systems which are extensible and interoperable within a larger architecture. Those are all very much consistent across what industry and our community is calling for, as well as what NASA is working towards as well. So we are taking your feedback now for this. The final release will be at our fall meeting. You can scan this QR code. If you're not already formally joined up for the LSIC, that's where our conversations will be ongoing. You too can have your inbox inundated with these emails. And I'll put these up again. You also should have cards on your table which have these QR codes to give you that information as well. We'll take feedback at any time through this email, lsic-feedback@jhuapl.edu. And so before I'll hand off to Rachel, I'll just say it's a great time to go to the moon together.
Thank you, Wes. And yeah, one thing, this white paper that's being put together, the goal is really to have a point of discussion of where the community would like to see things go. And so we really encourage you to provide feedback over lunch. We're going to be kind of circulating around and trying to understand how how it's being received and what we need to add to it. So we really want this to be something that we work all together. So I'm going to talk a little bit more about some of the activities that have been going on with LSIC. So, as a part of LSII, we are really meant to be this conduit for conversation between the community, especially a lot of the emerging industry members and academic members, and with NASA and the Space Technology Mission Directorate. So as Jim mentioned, we are spread out. We have participants from throughout the continental United States, throughout the world. We're institutionally, it's more weighted towards industry. As you can imagine, government collapses down a lot once you have just a handful of government agencies. Population-wise, we're almost equally distributed among these different populations. But we do have a lot of younger space companies, and not even space companies, but companies from technology or terrestrial technology, related technologies that we're trying to draw in so that we can have new exciting innovations that come from these translational technologies, where you can not only build towards this future lunar economy, but also market those on Earth and also help improve the quality of life on Earth here. So we have 4 objectives essentially, and that is to try to foster the growth of this diverse community, to draw in folks from across the nation, across the world into this cause, to help with resources, so developing and distributing resources. There are a lot of resources that are out there that the lunar science community is very familiar with, but a lot of those coming in from industry may not know about. We've spent a lot of money on those over the years. We want to make sure that you know how to access the LRO data, that you know how to make use of some of the models that are out there, so that we're not wasting everybody's money trying to duplicate efforts for things that have already been developed. And then, as Wes talked about in detail, we also really look at these needs and talk to the community to try to help Space Tech make smart investments and make the most of the money that they have. So there are way too many words on this slide, so I'm going to just kind of highlight it. We will be posting these online, so I wanted to provide the content there, but I'm just going to recap this and then walk through some of the work that the different focus areas have been doing for those of you that don't get inundated by emails, just so you can understand what kind of activities have gone on over the last 6 months or so. So in November, we had our fall meeting. In the fall meetings of each year, we have a technology invitational that's at a partner institution. This took place at the University of Texas at El Paso, and we had a lot of involvement from students there, as well as local businesses in the area. We also got to do some field trips, which were really fantastic. We went to see some of the 3D printed barracks at ICON and hear a lot about different activities. Mostly for this last fall, we were focused on lunar excavation and construction and proving grounds on Earth. And you'll see that's one of the themes that has come up over the years, is how do we test the technologies here? We can't fly everything to the moon and test it. How can we mature them as far as possible on Earth so that we're ready to deploy them on the lunar surface? So as I highlighted on this one, we had a number of findings that came out of that meeting. This continued drive towards lunar proving grounds is something that we're going to be talking about more at a workshop in June. So I will share that with you in a couple of minutes, a few slides later. And other findings include just continue to engage with the community. The community is very grateful that NASA wants to engage them in this process and in developing the architecture. We're really, really happy to see how this is evolving. And so there was, appreciation of that. And then finally, well, not finally, I have one more slide of these, but talking to industry and understanding how we can make these investments in a way that can help them still see a return on their investments is really important. So we want to continue to keep working the contracting mechanisms and whatnot to make sure that everyone leads to this better future where we can make, where businesses can succeed in this future. All right, another key finding was basically to hear more about the framework that NASA has laid out, and you're hearing more about that at this meeting. We're seeing more and more flush built onto the bones of the Moon to Mars architecture. There's a 150-plus page document out there now, so we want to commend NASA for putting that out and continuing to engage us. And then the thing that we would like to take forward, and as part of this white paper and also part of a workshop that we'll be having in the fall, is to understand, okay, once we get there, how do we begin to make this transition? How do we make this transition to other customers? How do we make the transition to industry supporting a lot of this? So I want you to all kind of think about that and what your vision is for that as we move forward. All right, so the focus groups, we have 3 focus groups. We have 6 total focus groups. 3 of them are sort of infrastructure elements, and 3 of them are more overreaching technologies and concerns, essentially. So I'm going to walk through quickly the 3 infrastructure element focus groups. So the surface power focus group, obviously deploying surface power is going to be a very key initial need. We have a number of folks that are working on the LSIC and the LSII side for this. I will leave this up, and for those who are here and in 200, can folks on the power team please stand up so that people know who to talk to? All right. As you can see, because we were overbooked, we restricted our team's seating in the main room. So hopefully a few folks stood up in 200 as well, but they'll be mingling around if you want to talk to them about surface power. So a couple of the things, just highlights that they've been working on recently, are understanding like how to deploy this initial grid for Artemis Base Camp that would support industrial scale ISRU, help grow the power research company. They've talked about rad-hardened electronics, power transmission, power storage, and they're going to continue these kind of dialogues going forward. Let's see. So May 25th, there's going to be an extended telecon to talk about the VSAT awardees. So if you'd like to join that, I encourage you to sign up for the surface power focus group. I'm going to breeze through them. So the next kind of infrastructure element is ISRU, so in situ resource utilization. They have initially focused on really utilization of oxygen and water and other volatiles on the lunar surface, but this has grown to really include metals. There's a lot of byproducts when you're working on this. And also talking about kind of this circular economy where you want all of your waste, you want to make use of it. Everything that is done and broken down, that metal's already metal. How do we plan now to make sure that the infrastructure we put up there works not only for its intended purpose, but can be repurposed or recycled to support a sustained presence on the lunar surface? ISRU folks who are here and in the other room, can you please stand up? Yay, hey, okay, thank you very much. All right. So as I mentioned, they've branched into talking about metals and whatnot, but they really want to focus on this goal of producing tens to hundreds of metric tons per year of water and or oxygen on the lunar surface. So really driving to this presence that can help support from local resources, support infrastructure on the lunar surface. Now, to do this, a lot of the discussion, especially in ISRU, has focused on what are the economics of ISRU? How do we build the partnerships to make sure that there are economics? So how do we connect potential buyers with the providers, and how do we build technology partnerships? So they're going to actually start having that more explicitly discussed in subgroups as we go forward. And they also want to look beyond just NASA as the sole customer. What are the things with, for instance, DARPA's Nomad program, which you'll hear more about, which would potentially use lunar resources? How can we make sure that everyone is kind of folded into this conversation? All right, and then the third infrastructure element is the excavation and construction. So this is all kinds of things. When I get to the next slide, I'll make sure that I don't forget any of those. But how do we lay out this large scale infrastructure? So whether it's habitats, whether it's roads, landing pads, those kind of things. What are you going to do autonomously? What do you need as far as maintenance of that can be done autonomously versus with humans? So, which we'll talk about more about that with extreme access, but basically what's the interplay between the autonomy as well as the excavation and construction? So they've really been trying to understand the master planning process and working with industry on that. And as the hosts of or co-hosts sort of with ISRU of the fall meeting, they've really tried to gather some of this information back from the community about testing things out, lunar proving grounds, especially for some of the large scale infrastructure elements that we'll be deploying. Excavation and construction folks in the room, can you stand up, please? There's Jibu back there. Hey, all right. Hopefully there's mad cheering going on and Mark in 200. You guys got to get riled up. Let's go. All right. I don't know. I need some kind of like a crazy clown horn or something like that to get people going. All right. So the three focus groups that are kind of overarching are extreme access, which is kind of like, how do you get in these places? How do you navigate them? How do you know where you are? Extreme environments, which of course are all kinds of things, thermal, radiation, all the things that we have to deal with. And then dust is its own thing, because lunar dust and dealing with lunar dust is this overarching group that we really don't want to ignore when we're planning for this. So extreme access, as I said, that includes autonomy, it includes robotics across all the different elements, mobility, communications technology, position, navigation, and timing. And with this, as well as with extreme environments, because these are such diverse topics, a lot of the work goes on in subgroups. So if you join one of the LSIC lists, but one of these is your interest areas, you want to probably participate in the subgroup meetings to discuss these in more detail. Can the folks from EA also stand up, please? We got Angela over there. And is Josh here or no? No, okay. So they're really, this year, what they're considering focusing on is understanding that the autonomy and robotics technology requirements and desirements to enable both excavation and the ISRU activity. So really looking at this interplay between autonomy, robotics, and deployment of these infrastructure elements. They've been contributing to this white paper that we're putting together, and then sharing a lot of the results of the analyses with the group. Dust mitigation, as anyone who works on the moon knows, is kind of a gnarly subject. Dust gets into everything. It's extremely abrasive. It's hazardous both to humans and to technology. The focus through LSIC is mostly on the technology risks of dust, because there's a whole other side of NASA that's focusing really heavily on the human side of things. But we still have to worry about seals. We have to worry about, in fact, maybe it's even here. So isolation technologies, materials and coatings, how can we deal with this sticky dust situation? I'm going to flip right back while we still have the pictures. Can Jorge, you were here, I think this morning. Yeah, well, Jorge's back there. And then hopefully if we've got some of the dust folks across the street, they will stand up as well. Oh, and Kristen is here. Yeah, you'll see Kristen more tomorrow. Yeah. Okay, so they want to assess the dust mitigation needs and the technologies that are available, and work to figure out what terrestrial technology is out there that could be matured for the space environment and potentially be used for some of the dust mitigation work. They're trying to build up their subgroups. So if you're interested in any of these, please look at, fill out the survey that's linked on here, and these will be in the slides. And what they're trying to figure out not only is how do you isolate the dust, but how do you decide what's too dirty, what can be operated dirty, what has to be maintained as pristine as possible. How can we test these things? How can we model the behavior of dust on the lunar surface? Are there key experiments that need to be flown on these early missions to make sure that we have the inputs we need to make sure the models are correct and to really understand these issues that we'll be dealing with. And so finally, the extreme environments focus group is again this overarching group that looks at the effects of the unique environment on the lunar surface. And what they've been really working towards is helping gather the resources and put together guidelines for folks to understand how to operate in these environments. So as you heard, Milena is putting together kind of this 101 type in engineering to help understand what the implications are. So when people are coming into this community new from the terrestrial environment, they can understand some of the differences that they need to be designing towards. They're also, here, let me go ahead and flip to that. working on interacting with the different groups and doing crosstalk meetings where they can come in and provide the subject matter experts to talk about the radiation environment, other hazards that are present. So once again, I flipped before I told people to stand. EE folks that are in here, Milena, all right, and Kevin and Karen, excellent. So again, they're looking at near-term and long-term technology gaps, looking at guidelines and requirements for hardware design and environmental testing, and doing a lot of these crosstalks with others. And I'm going to stay on time. I really am. Okay, so we started with those 6 focus areas, but we realized over 3 years of meeting, there are other areas that really need their own separate discussions. And one of these areas that the community told us again and again, we really needed to talk about now is interoperability. And this is huge. We mentioned kind of standards, but really like the key, standards can mean a lot of things, and that has to be worked, but interoperability right now and designing for it, and ideally engaging the international community in that, is just really, really key to make sure that we can operate on the lunar surface and have this sustained presence on the lunar surface. So we have what was formerly branded the MOSA, Modular Open Systems Approach Working Group, is kind of morphing into interoperability and looking MOSA as a solution to a problem. We want to look a little bit broader than that, basically, and have these discussions going on. So this is James Mastandria, I believe is our key point person in the other room right now, but he'll be roaming back and forth if you want to talk to them about any of this, but we're really trying to understand what are the most key things. Oh, is he here now? And Kristen is here. So Kristen, go ahead and stand up. So Kristen's in here, James is in the other room, and they're working together to bring these discussions to the forefront and having ongoing telecons and mailing lists. So you can, you too can have a mailbox full of emails that say LSIC. You can choose. No, okay. So to be clear, if you sign up today, and if you do not click the different groups, you will only get about one a month. But if you click the different groups, you'll get a lot, because we do have a lot of work going on. Yeah, the first one, the main one, announcement, you get a newsletter of what's kind of summarizes what's going on. And a couple emails from me about funding opportunities every once in a while. So the other really important overarching working group that we've established is the Lunar Simulants Working Group. And this is working in partnership with folks at NASA to really understand what simulants are out there, because we need something to test on. We can't just test on lunar soils. Unfortunately, we don't have enough of those. And what are the best ones for your application? So where can you get them? And what are their chemical properties, their physical properties, so that for the particular application that you're testing for, you know how to choose the right one. So they're actually going to start like a seminar series. It won't be a monthly, probably won't be monthly the way that the other focus group meetings are, but something that really provides increased dialogue across the simulant community. All right, a couple more workshops, and then I will hand off to Josh. So as I mentioned earlier, we're going to be hosting a Lunar Proving Grounds workshop, which I said June, but I guess it's July. I apologize for that. So that will be, I believe here, I think this is our first workshop. So this will be an actual in-person component workshop. Normally we try to do the workshops virtually to make sure that folks can participate across the country. But this one, we think it's important to get people together speaking in person as well. So that will be here. Yeah, it'll be hybrid too. So yeah, we have not done anything fully in person since COVID, because we realized we could really reach a much larger community by not requiring people to necessarily travel to participate. And that's part of why we do Slido as well. So you can all have kind of a even playing level, whatever, you know what I'm trying to say, for asking questions. And is Blanca Lara here? I couldn't find a picture. If she is here and can stand up. No, okay. So there's also going to be a surface power reliability workshop in July, later in July, and this will be via Zoom, and they'll be talking about reliability. Yeah, it's in the title. And bringing in different folks from industry, from NASA, to discuss this and really think about how do we ensure reliability for the surface power grid. All right. We've been watching closed caption on our TVs like lately, and they have like clicks tongue, like they'll write it out. And every time I click my tongue now, I'm like, oh God, I'm so sorry, everyone. All right. So I invite you, if you're not already part of LSIC, please, I invite you to join us. We welcome people from throughout the world to join into this conversation, and we will make sure that the things you talk about get flown back up to NASA. And we are one opportunity for you to have this conduit in this discussion as they evolve the architecture. I walked through each of the workshops. The other big save the dates that I wanted to share with you, our fall meeting is going to be held in October between the 10th and the 12th. That will be hybrid, and that's going to be in Pittsburgh at the Community College of Allegheny County, and that's in partnership with the Keystone Space Collaborative, as well as Astrobotic will be working with us. So as part of that, we're also going to be doing this transition to industry workshop, which will be either the first or the last day. We're still kind of working out the details on that. And so that we can get in a bigger room next year and have everyone together, we have pre-reserved the Kostyakov Center, which is across the street. And we will be holding this meeting the week of April 22nd. So hopefully everyone can be together for that one. So if you want to sign up to participate, please do. And if you're interested in hosting a future fall meeting, we have a place where you can apply for that on the website. And I will hand off to Josh. Thanks very much. So Josh is the Deputy Director of LSIC.
Thank you, Rachel. My name is Josh Cahill. I'm the Deputy Director of LSIC, and Rachel makes it easy. So I want to thank her while I have the chance. So I wanted to give you a brief idea of something we just rolled out very quietly within the last couple months, and that's our access to space interface. A little bit of background leading up to its creation. We've been kicking around the idea of this kind of directory or interface to keep track of all the opportunities coming up, because they're coming out really quickly now, and trying to keep up with just how much resources they have available left to take advantage of. Because it's not just going to be NASA that is going to be taking advantage of the space on that. It wasn't designed to be that way. So one of the things that was kicked around at League last year, and then again Eclipse, was the conversations in some of the breakout panels often came back to, well, when's this marketplace going to be kind of created? And so that kind of gave us a little bit of a nudge. And so part of that conversation at League was asking, with one of the particular Eclipse parameters that I think they're in the audience, was that we have X number of kilograms left of resources left to take advantage of. It's like, well, that's exactly the kind of thing we're looking for. So that kind of gave us the impetus. All right, we'll start putting it together, and we'll try to make it simple and straightforward. So here's a beginning look at the interface. It's organized by host payload or host provider. So you have your lander, surface mobility, cislunar, and suborbital. It's one of the reasons we didn't just call it lunar, but because there's a pathway to get to the lunar surface. There will be payloads that are lucky enough to go straight to the lunar surface. We have to recognize that a lot of them are going to take iteration and development along the way. It's only realistic. Also, so host vendors can submit their own entry. However, as a community, as LSII and the multiple hats we're kind of wearing, we're trying to keep up to date with what's going on. So we do our own research. If an entry's not there, if we feel like we have enough information, we'll put an entry that will explicitly say where it's from, who wrote the entry, and then if a provider sees it and wants to update it, then we'll go ahead and do that. But the gold standard is for the provider to actually provide that entry. Okay. Something I should also point out is that you'll see that payloads and services is also a couple of tabs over here. When we initially envisioned this, we did not envision putting payloads and services on here. That was specifically an Eclipse request by several of them. So at this point, we're kind of anemic on the payload side. So we're asking for payloads. They don't have to be absolutely ready for space. That's why the TRL classification is there. So you can kind of give an idea. We just heard some speakers saying we need to be thinking 10, 20, 30 years out. That can the providers and their business plans can kind of keep track of the kind of businesses coming down the road in that particular context. This is also in recognition that not all the payloads coming out that you might see in TechPort are sustained by NASA. So we also have in the next iteration, actually it's one more slide over, a couple key pieces of information that we have is a brief summary. It's limited to about 1,000 characters. We're not intending to be comprehensive, all right? We're intending to kind of give you a brief snapshot of the resources available on that particular host provider, a point of contact, and an idea of what kind of resources are available. And we give you a lot of flexibility on what kind of resources are available. You can either say precisely how many kilograms are left, how many watts are left, or you can say we have about half our payload left, capacity left to manifest. Some of that stuff is proprietary, competitive in nature. So we've tried to provide as much flexibility as possible when listing that. But the real keys here are if we can get a point of contact so the person can know who in particular is the stuck he with generating business and knowing what's going on and so forth. There's also room to provide a spec sheet as noted there. And here's the kind of entry. We keep it simple, type of payload. Some of these CLPS flights are, they're manifest at this point, whether they're filled or not, or static. But that doesn't mean that all options are off the table in terms of data that can come back. You can also have data-only payloads listed. They can list whether they're open or not to that. You can consider if they're open or not for data buys. So if they're open to it, you can contact them and see what kind of instruments they have going that they'd be willing to potentially let you have access to that data for whatever scheme they have in place. One of the other requests we also had was funding. Okay, so payloads, the host providers, they're going to have development phases, and then they're going to have flight phases of funding. We're asked to kind of separate those. So if you, we can have two particular categories in here in terms of the type of funding that's occurring. You can tell us if it's a development payload funding, or if it's actually meant for flight, if it's ready. And CLPS vendors were pretty keen on that. We'd like to be able to differentiate whether they're just ready to go, or if they are in development phase, which is still where we're interested in potentially talking to them. So that's something to keep in mind as well. Okay, so what does it provide? Hopefully it's kind of an initial centralized place that can be considered a marketplace. There's no pricing scheme in this. It's mainly just information, kind of a clearinghouse of sorts that connects one opportunity with the other opportunity. It's kind of an introductory place that's open to the community. You get a certain level of advertising for sure. And there are other parts of particular payloads, even some that may be going to the moon recently, that may be open to discussions in terms of data that might be available to purchase or whatnot. Okay. Hopefully we can keep this closer real time with the CLPS providers and the payload providers. There is, some flexibility to that. We've made it so it's not listed by the day, it's listed by the quarter. So if launches slip, there's a little bit of flexibility in terms of accuracy. And it's important to keep in mind that LSII and LSIC in our multiple HAPs, we are in this position to advise NASA. So if there is still space on a particular CLPS host, and for some reason, a payload is ready to go from STMD, and they ask us, do you have a handful of potential opportunities? It'd be nice to know what they potentially might be. So anyway, I think that's where I wrap up things. I think Wes is going to introduce you to what's going on in the next session, and thank you for your time.
That's good. That's good.
Yeah, so I'll be around the next 2 days if you'd like to talk about it. I'll just be wandering halls. Thanks.
Wandering the halls. All right, I'll find you. I'll bump into you. So yeah, we're coming up on lunch, and actually we're going to get you out to lunch on time. Can you go back to slide 12 from this presentation, if you will? So over lunch, we've got time more than enough time just to put your lunch into your mouth and eat it, take a little walk around. But we've also got time that we want you to use to have a look at this white paper that we've put together. We've got Reeve. I don't know if Reeve is, he might be out right now. He's got to work and bring in some posters that you'll be able to put your thoughts directly on them over your lunch period. So have conversations about the topics that we've brought up here, as well as the other things that you care so deeply about. And let us know. So if you go and follow that QR code, you'll see our LSIC resources. And one of the sections of that is this community white paper. A brief little overview of what we're trying to accomplish with it and how we've engaged the community, as well as the draft of it and an email address where you can send feedback anytime. And we'll look forward to whatever content you can give us on that. And we'll do our best to reflect the community as we always do. And yeah, look forward to talking to you more over lunch and over the next couple of days. We've built a lot of time into our agenda for you to have a time where you can make deep and meaningful connections across the communities that you work in. So thank you very much. Enjoy your lunch.